Welcome viewers, in this video we will see the solved problem based on the regulation of the transformer part 2. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the problem. First we will see the first problem, problem 1. Calculate the value of voltage regulation at 0.8 power factor lagging for a transformer with resistance drop is 2% and reactant drop is 4% of the voltage. So the power factor is given and resistance drop and reactant drop is given. So from this we can analyze the given data. The power factor cos pi equal to 0.8. If cos pi is 0.8 mean automatically we can write sin pi equal to 0.6. And the resistance drop is given, that is denoted by VR. So VR is nothing but R2 I2 R02 divided by no load secondary voltage V20, right? So this is given as 2%. So the resistive drop is VR, that is nothing but I2 R02 divided by secondary terminal voltage, that is equal to no load secondary voltage, that is equal to 2. Similarly, the reactance drop Vx is nothing but I2 X02 divided by secondary no load voltage, that is given as 4%. So these are all the data given. From that we need to find the voltage regulation. So the voltage regulation is the formula is I2 R02 cos pi plus or minus I2 X02 sin pi divided by no load secondary voltage. Now we'll split the terms. I2 R02 divided by no load secondary voltage into cos pi plus or minus I2 X02 divided by no load secondary voltage into sin pi. So this I2 R02 divided by no load secondary voltage is VR, because VR value is given. So into cos pi plus or minus I2 X02 divided by no load secondary voltage, that is nothing but Vx, the reactance drop, into sin pi, because these two values are given. So that we can take this is the VR and this term as Vx, and plus or minus is given. This plus for lagging power factor, minus for leading power factor. So in this problem it is given as lagging, so we can take plus symbol. So 2 into the resistance drop is 2 into 0.8, cos pi is 0.8 plus for lagging. Vx is reactance drop is 4 and the sin pi value is 0.6. So by simplifying this we got it is 4%. The voltage regulation for the given problem is 4%. Now we will go to the second problem. A transformer has reactive drop of 6% and the resistance drop of 2.5%. Determine the lagging power factor at which the voltage regulation is maximum and the value of regulation. So the resistance drop and reactant drop is given. The power factor, we need to find the power factor, lagging power factor, and the condition given is voltage regulation is maximum, and also we need to find the value of the regulation, right? So the two data given in this problem is resistance drop and reactance drop. Resistance drop VR is taken as VR, that is nothing but I2 R02 divided by no load secondary voltage, that is equal to 2.5%. Similarly, the reactance drop Vx equal to I2 X02 divided by no load secondary voltage, that is given as 6%, that is 6. So we have two data, VR and Vx. Now we will see what is the condition for maximum efficiency. Maximum regulation, not efficiency, maximum regulation is tan pi equal to X02 divided by R02. So the regulation will be maximum at this condition, tan pi equal to X02 divided by R02. So first we will find the X02 and R02. So VR is given I2 R2 divided by no load secondary voltage, that is 2.5. So from that R02 multiply this secondary voltage here and bring these two terms in the denominator, so that R02 equal to 2.5 into no load secondary voltage divided by I2, right? So this equation is rearranged in so that we can find the R02 value. Similarly, Vx is given as I2 X02 divided by no load secondary voltage, that is 6. Now multiply, bring this V02 in the numerator, bring the I2 in the denominator, so that X02 equal to 6 into no load secondary voltage divided by I2. So from the resistive drop and reactance drop, we frame the equation for R02 and X02, right, in terms of no load secondary voltage. Now we can substitute these two values for a maximum regulation. So the condition for maximum regulation is tan pi equal to X02 divided by R02. So the X02 is nothing but 6 into no load secondary voltage divided by I2. Then R02 is nothing but 2.5 into no load secondary voltage divided by I2. So this I2 got cancelled, no load secondary voltage also got cancelled. So what we have 6 divided by 2.5, right. So tan pi equal to 6 divided by 2.5. So 6 divided by 2.5 is 4. So that tan pi equal to 4. From that pi equal to tan inverse 4, that is equal to 67.38. So the pi value is 67.38. From that we can calculate the power factor. Value. So pi value is 67.38. So that cos pi equal to cos into 67.38, that is nothing but 0.385 lagging, right. So the first question we need to find the power factor for lagging, that is nothing but 0.385. Next we need to find the maximum regulation. So this is the condition for maximum regulation. At this condition we got the power factor as 0.385. Next we need to find the maximum regulation also. In that we need a sin pi value. So that sin pi equal to sin 67.38, this value. So that is nothing but 0.923 lagging. So this is the cos pi value, this is sin pi value. So by using these two we can able to find the maximum regulation. So the maximum regulation equal to VR cos pi plus Vx sin pi. So VR is already given, it is 2.5. Cos pi value is 0.385, that we calculated, and Vx is 6%, then sin pi is 0.923. So all values are substituted. So by simplifying this we got 6.5%. So the regulation for a maximum regulation is 6.5%. For that, under that maximum regulation, the power factor is 0.385 lagging. The corresponding value of sin pi is 0.923 lagging. So in this problem, we calculated the power factor for maximum regulation as well as the value of maximum regulation for that given condition. The data given is voltage drop and reactant drop, resistance drop and reactant drops are given. So we discussed two problems based on the regulation. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.